Good morning, everyone. As you know, all Android apps have to be code-signed to run on a device. This is either performed directly by you, the developer, or through Play app signing. Despite every app needing to be code-signed, I've found that the processes around the signing are increasingly abstracted away from the developer. This has resulted in code signing becoming shrouded in mystery. I'm Neal Michie, Director of Product Management at Pace Anti-Piracy, and a long-time Android developer. I worked out 14 years as I was coming in this morning. And code signing interests me for two reasons. Firstly, I've noticed through my work that it trips up a lot of developers. As soon as they're moved out of their usual build environment, away from their familiar build pipeline. And secondly, I find it interesting because Pace has its own code signing platform. Not used on Android, but used in places like Avid's Pro Tools ecosystem for audio production. So what is code signing? And why is it important to us as developers? Well, most modern operating systems require applications to be code signed. And it's basically a cryptographic hash of the application binary, the classes, and all the resources that make up the application. On Android, we can't even install an app onto a device if it's not been code signed, if it doesn't have a valid signature. So let's look at this and see how it actually plays out in practice. So I need to... Hopefully you can see that. It's a little bit smaller here, right? So down the bottom, I have an APK. This is an unsigned application. If I try and install it on a phone or into the emulator, the behavior is the same. Nothing happens. It just ignores it. If I use ADB, we get a bit more information. I don't know if that's too small. Let's make it a bit bigger. So it's telling us it's failing to install because there's no certificates. We'd expect that. It's not been signed. And I can use, let's put that down there. So I can use, behave. I can use APK Signer to sign this APK. Has anyone used APK Signer directly rather than through Android Studio? Yeah, one person, I think, is admitting to using it directly, illustrating my point about how this gets abstracted away these days. But there is a tool to sign APKs on the command line. It's called APK Signer. We want to sign this one. We need to give it a key store. I have an imaginatively named one called Test Key Store. And we need to tell it which key within the store we want to use. And then we need to tell it the APK we want to sign. You can do this inline and sign the one that you've got there. But to keep my demo intact, I'm going to create a new copy of the APK. And the key store needs a password. And it's signed. And you can see down the bottom, we now have a signed APK that if I install, just to prove the drag and drop does work, if I install it, you can see in the middle there, we now have a nice Pace icon on an application that previously wouldn't install. Now it's been signed. It installs. So we'll get rid of that. Or not. So we've signed the APK. Great. What we can now do is let's have a look inside the APK and see what we've actually done by signing it. So if I unzip the signed APK, you see down here, we now have our folder containing all the contents of your APK. So in there we have the manifest, we have the classes, all the code. We also have this folder called meta-inf. In here, there's a lot of metadata. But down here, we find a file called manifest.mf, which really comes from the history of the APKs, which is the jar format. And in here, we have SHA-256 hashes of every file that's within that APK, including interesting things like our classes decks, our code. So if that hash can't be validated by the operating system, it deems the APK corrupted, and it won't let it install. If the hash isn't there, it won't let it install. So I can't change any of these files now it's been signed, because the hash needs to verify. The public key, this is public key cryptography. The private key's in my key store. That's safe to me. The public key is embedded in the APK, and it doesn't open very nicely in the text editor, but it is there. And that public key is then used to validate by the operating system. It uses that public key to validate all those hashes as you install. So anyone can validate, and anyone can do that, but it's done as part of the operating system install. What I can also do is, the public key's in there. There's nothing stopping me just re-signing this, being someone else. I'm a hacker, I've got hold of your app. I want to re-sign it for my own purposes. Nothing stops me doing that. So if we go back up and we use APK Signer again and sign it, we'll use the same key store, but we'll use a different key in the key store as if we're a different person. Imaginatively, it's called key 1. And our input this time is the signed APK, and we'll output this just to we now have, if we come up here, we now have the re-signed APK. Right. And if I try and install the re-signed APK, we see some of Android's protection starting to work, because we get an error. It's telling us, if you look at the bottom of the tracing, the signatures don't match. I've signed it with a different key to the one installed, so Android won't let me update it. Of course, if I never had it installed in the first place, just pretend it was never there, I can now drag it on, and it's installed with a different key. Right, cool. So what's the point of all this? Why do we go to the effort of signing the apps? Well, I think as we just shown, the signature identifies the last person to modify the app. Normally that's the developer, but in many large organizations, development and release are split into different teams. So it's not always the developer working on it, it could be someone in the release team. But equally, this could just be someone that's trying to hack the app and get it running, kind of after making modifications or changes to it. So really what the signing is there to do is to imply ownership of the app as it's being installed. It's really a case of responsibility falling on the last person to touch it. They're responsible. It's a bit like code and bugs. You're the last one to touch it, you're responsible for it. And now, Android doesn't act as a certificate authority or keep a list of valid certs in any way. The certificate I used a minute ago was a self-signed one. I created it. I've never given it to Google, never given it to Android in any way. So unlike Pace's code signing platform, this isn't a full PKI system. No one is kind of controlling this. So how does the ownership play out in practice? Well, firstly, as we saw, you can't install a version of the app with a different signature to a previous one. So this gives the users some confidence that version 2 of the app has come from the same developer as version 1. That's good. That protects against phishing attacks where a user is tricked into trying to install the plus version of an app onto their phone. It's not going to install nicely. They're going to have to delete and reinstall, and that should start to trigger some alarm bells. So if someone's trying to trick users into installing the ad-free version of your app, then they're going to struggle to do that. They're going to struggle to use it as a way to deliver malware. Secondly, the signing is used to help define the OS sandboxes. As you know, Android creates sandboxes around your app when it's running to protect it from bad actors on the phone, stop other apps interacting with your app in a way that you don't want it to. If you have 2 apps or more apps signed with the same key, that allows you to reduce some of the sandboxing and have the apps interoperate more directly with each other. With that sandboxing in place, to have the apps talk, you've either got to go through OS official channels or start to resort to basically hacking techniques to get the apps to talk. So the sandboxing allows you to have multiple apps from the same developer. The signing allows you to have multiple apps from the same developer work together more closely than 2 totally separate, unknown apps. Right, so far, so good. We've created a certificate, we've signed our APK using APK Signer, and then Android's let us install that onto the phone. And as I think we demonstrated earlier, where only one person had used APK Signer directly, Android Studio and the other IDEs really simplify the process of signing. Either they do it quietly when we're pushing builds to a phone for testing and debugging purposes. Just quietly signed and put on the phone without you even really knowing about it. And even when you want to explicitly create a signed APK, there's a nice option from the menu to do that. You don't have to resort to trying to remember your password of the key store and all the commands to do all that. So nice and simple, except you've probably noticed 2 flaws with this plan. First, we don't give Google APKs anymore. We upload app bundles, AABs. Secondly, there's this thing called Play App Signing. So I'm going to ignore the app bundle compilation now. We'll come back to that in a second. But let's look at this classic flow, the developer signing. We understand it now. As a developer, you sign the app, you upload it to Google, Google downloads it to the users. Job done. Happy user. Play signing, play app signing is slightly more complicated because Google re-signs the app before it's downloaded to the end user. And remember we saw how easy it was to re-sign the APK. Doesn't matter if it's been signed before or not. Anyone can re-sign it. So what the user gets isn't signed by your certificate. It's signed by a certificate Google manages. And 90% of the time, that's a certificate Google has also created for you. In this model, the key that you signed as a developer, it's effectively renamed as an upload key. It's used by Google to validate kind of you're the same developer giving it APKs. And what's fun is, while we're not calling it an upload key, it's actually still a valid certificate. You can install this APK on the phone for your testing and your debugging. My experience is a lot of developers don't realize that this place signing is even happening. It's happening in the background quietly by Google. And I've seen that cause problems where people rely on their certificates. And in fairness, the developer console is now much better than it used to be at making you aware your choices and what's going on. There was a spell where Play was quietly forcing any new apps to use Play signing. And it didn't make it very obvious that was going on. Thankfully, we now have screens like this that make it very clear what your choices are and what options you're taking. And having Google manage your certificates is generally a good thing. You're not going to forget passwords or have key developer leaves the team and someone else comes in and can't get access to those certificates. And if it's all managed nicely as part of your developer account, and that's generally a good thing. But if you're relying on that certificate for anything, then you're going to need to be aware that it's being re-signed. Typical dependencies, typical reasons to rely on it are security related. You want to make sure someone's not re-signing your app. You want to validate the integrity of your package. So thankfully, kind of Google does give you the details of the certificate it's using. So if you are going to rely on that within your app, you can get all the details you need to validate your own certificates. And what about app bundles? What about AABs? It's kind of where we started this thread. Well, AABs are a bundle of assets that allow Google to create the APK. So we can create the APKs. What we also need is to sign those APKs so they can be installed onto a phone. Hopefully self-explanatory, but with Play signing, Google can sign those APKs. So you give it the app bundle with everything you need to create an application. Google has the signature to sign the APK it creates. We're all good. Basically, Play app signing allows AABs to work. It's kind of part of the infrastructure that allows AABs to be turned into APKs and downloaded onto the phone. All right, I've spent a lot of time working with developers building secure mobile apps. And a phrase I hear a lot is, my code is signed. I'm secure. I'm safe. Sorry, no. As I showed, anyone can re-sign your code. And code signing is there to protect the ecosystem. It's there to protect Android, not your code or you as developers. Platforms implement code signing for their own purposes, not for your purposes as developers. And when we look at that, just very quickly, if we look at the APK we just signed with a hacking tool that decompiles APKs, so the one we signed, I need to stop. There we go. So opening up that signed APK, in here we can see all the source code. We've minified it with R8, but still, if we wanted to very quickly search for something secret that we maybe wouldn't want to be revealed, like an API key, bang. There we go. Very quickly, we've found a secret within the code. It's related to usernames, passwords. There's an API key. There's even a URL for a login. So we're finding things in the app that would allow us to then talk to and attack the back end. And this is a signed app, so the code signing is not protecting our code. So what we need to do is go beyond code signing. And if you have anything sensitive within your code, then you should go beyond code signing and protect it yourself. That means using code protection technology, real obfuscation, not just minification, but actually real obfuscation that strongly protects your code. Runtime checks to validate the device your app's running on is a real device that's not been compromised. And binary integrity checking, actually self-checking our code to make sure that someone's not modified or manipulated it or using it out of context. And there's a few companies on the show floor downstairs that do this well. And if you want to go further, we highly recommend at Pace that you use white box cryptography. We have a lot of expertise in Pace at white box technology, because white box provides beyond obfuscation protection. It provides targeted protection of critical algorithms, stopping reverse engineering, and the secrets within those algorithms, cryptographic keys, other data that we wouldn't want to be exposed. So there we have it. A lightning overview of code signing within the Android ecosystem. And remember, it's always happening, but it can be, and often is, hidden from the developer. And also remember, it's there to protect Android, the ecosystem your app's running in. It's not there to protect your code or your application. To do that, we need to use advanced code protection and make sure that we really protect that code. If you want to discuss further, please come down to the Pace stand. We're downstairs near the coffee. Happy to discuss signing, code protection, or why trick-or-treating is wrong and we should really be going guising. Thank you.